In today's lesson, we're going to be talking about the cosine law. So we had spent some time looking at the sine law. I'll put a link in the top right-hand corner if you need a refresh on the sine law and how you use it. But there were some limitations to the sine law, and let's take a look at the following two triangles to see what they are. Okay, look at the triangle on the left-hand side here. Looking at the triangle on the left-hand side, let's say we wanted to solve for the length x here. First of all, it's not a right angle triangle, so I can't really approach it using our basic sine theta, cos theta, tan theta ratios. If I want to solve this using the sine law, we would say, okay, well, x divided by the sine of 35, so x divided by the sine of 35, well, what does that equal? That would equal, I have some options here. I can do 12 divided by, I do not have this angle and cannot find it currently. Or I can take the length of 15 and divide that by the sine of this angle. And once again, I do not have that angle and have no way to solve it. So if you went and set this up, you would go 15 over sine. You have to introduce another variable here, right? And then now we have a problem. So this triangle in its current form cannot be solved using the sine law. Triangles in this form have a particular name to them. In this case here, this is a special triangle. It's called side, angle, side. Side, angle, side triangle. When you have a side, angle, side triangle, you cannot solve it using the sine law. Likewise, take a look on the right-hand side. If I want to solve for this angle here, theta, and we wanted to approach this using the sine law, I would first take the sine of theta and divide that by 15. And that'll equal, I can either take the sine of this angle, which I don't know what it is, so maybe I'd have to introduce a new variable, divided by, in this case, I could go 12. But obviously you can see the problem here. We have one equation and two unknowns. So sine law once again falls apart. This triangle also has a specific name. This triangle also has a specific name. It is called side, side, side. So if you have side, 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 you also cannot solve it using the sine law. In these situations, what we want to use is what's called the cosine law. So what is a formula for the cosine law? Okay, let's say we got a triangle here. Let's label this A, B, and C. What the cosine law says is, again, across from angle A is length of this leg of the triangle, lowercase a. Across from angle C, we have lowercase c. And across from angle B, we have lowercase b for the lengths of the legs A, B, and C. So here's the relationship. Let's pick one of these first. There's actually three equations here. First equation is going to be A with respect to A first. So we're going to have here equation 1, you have A squared equals B squared plus C squared minus 2BC to the cos of angle A. So notice here, A squared is going to equal the sum of the squares of the other legs of the triangle minus 2BC over the cos of the angle. And notice the symmetry here. This happens often when you're creating your equations, and it's a good way to help you memorize the formulas here. The next one is going to be B squared. It's going to be the sum of the squares of the other legs minus twice the product of those other legs times the cos of that angle B, capital B. And lastly, we have our final formula. In this case here, C squared is going to be the sum of the squares of the other legs of the triangle minus 2 times the product of those legs times the cos of angle C. And again, just to highlight this for you a bit more, we've got here A with A, B with B, C with C. And you can see here that the other B, C, B, C are involved here. A, C, A, C, A, B, A, B. Hopefully that helps you kind of memorize the formula. A lot of times students think that, okay, I've got 3 different formulas to memorize. It's not the case. You just have the one. Okay, let's take a look at solving some of these problems that require the cosine law. All right, so for our first triangle here, again, nothing's labeled. I would label this, again, A going clockwise, B and C. Across from angle A, we'll label this lowercase a. Across from angle B, label it lowercase b. And across from angle C, lowercase c. They want me to solve for x. I'm just going to leave that as a c instead so I can match my formula. So they want me to solve for c here. Notice for this triangle here, we have side, angle, side. So this is a side angle side triangle, and because of that, I can solve this using the cosine law. So I'm looking to solve for c here, so my equation is going to be c squared is a squared plus b squared minus 2ab cos of angle c. Okay, let's fill in what we know. Well, c squared is what I want to solve for. A squared is going to be 15, so we got 15 squared plus 12 squared minus 2 times 15 times 12 to the cos of 35 degrees. So now if you look at this here, how would we evaluate this? I'm going to go ahead and evaluate this. C squared is going to equal 15 squared plus 12 squared is equal to 369 minus, the biggest mistake students make is they forget that this is all one operation, all one expression, I should say, that you want to calculate, right? You can't put together the 369 and these expressions here. This is all tied together in one operation through multiplication. So I'm going to calculate 2 times 15 times 12 times the cos of 30. And if you do that, you get 294.89 approximately. Subtracting these two, we get 74.11. And lastly, taking the square root, we get 8.61 units approximately. So therefore, we're able to solve for the length of this side of the triangle using our cosine law, and your c value, like we just said, is approximately 8.61. Okay, let's take a look at another problem. So for this triangle here, again, we want to solve for angle theta here. Notice here we have side, side, side. So this is a side, side, side problem. And to solve this, this is a cosine problem. So again, the triangle is not labeled. Let me label this. So we're going to go A, B, and C. Across from angle A, we have our length of side A. Across from angle C, our length of side C. And lastly, angle B. So I'm looking to solve for angle C here. The only formula that we have that incorporates angle C would be this one. C squared is a squared plus b squared minus 2ab cos of c, right? Now, we want to find this value right here. I want to find that angle C. We actually have all of these. I know what C is, I know what A is, I know what B is, and obviously I know the product of those two as well. So the technique here, what we're going to do, we're going to sub everything we know into the equation and then try to solve for angle C here. So let's go ahead and do that. Okay, so my value of C here is 15. That's going to equal A, which is 22, plus B, which is 12, minus 2 times 22 times 12 to the cos of C. So let's follow along the math here. 15 squared is 225. If I take 22 squared plus 12 squared, we get 628. And again, I'm going to multiply these three numbers together, in which case we get minus 528 cos of C. So in this situation here, we're looking to solve for C. Before I can go ahead and get C by itself, I'm going to have to subtract 628 on both sides. Again, you cannot subtract these two together. I cannot simplify this to be 100 cos C, and the reason for that is you have multiplication happening between these two expressions. So subtract off the 628, and we get negative 457 equals negative 528 cos of C. Divide across the minus 528, divide across the minus 528, and we get the cos of C is approximately equal to 0.866. At this point here, I'm going to take my cos inverse, and we get approximately 30 degrees. Okay, so therefore angle C here is 30 degrees. All right, let's take a look at another problem. So in this problem here, we have two scuba divers are 20 meters apart. They spot a shark below them. The angle of depression from one diver to the shark is 47, and while the angle of depression from the other diver to that shark is 40. How far are each of the divers from the shark? All right, let's try to draw this diagram here. All right, let's take a look at the problem here. I've drawn the diagram, and you'll notice here the distance between the divers, as I say in the question, is 20. I'm making the assumption here that the divers are 20 meters apart, perfectly horizontal apart. So they're not off at an angle here. I'm assuming they're both exactly 20 meters apart horizontally. So now if we keep reading here, they had said, okay, the angle of depression to the shark for one diver is 40 degrees. The other diver is 47 degrees. And they want us to find the x and the y here. So in this case here, notice we could actually solve this question using our sine law. Like if I want to solve for this here, I know that I have my x value and I have my angle. So this would be x over the sine of 47 equals, I could go to this length here, so 20 over, I can find this angle. I know it has to add up to 180. So in this case here, it would be 93 degrees. So this will be the sine of 93 degrees. Multiply across by sine 47, and I get x is approximately equal to 14.65. Okay, so now I want to solve for the other length here, y. We could solve this pretty quickly just using the sine law, but what I want to do here is I want to go through the cosine law and show you guys how to do that here. So if you want to use the cosine law, I want to label this properly. Label this with an A, a B, and a C, and we're interested in finding length A. If I want to find length A here, it's going to be A squared is sum of the squares of the legs of the triangle minus 2BC to the cos of angle A. In this case here, you get A squared equals, approximately equal, I should say, 14.65 squared plus 20 squared minus 2 times 14.65 times that 20 times the cos of angle A. And in this case here, we know what angle A is. Angle A is 40. So if you punch this all in your calculator all the way across, you get approximately 165.72. And taking the square root, we get approximately 12.87. So the length, the distance that this diver is from the shark is 12.87 meters, whereas this diver is 14.65 meters. All right, again, I would recommend to just do this using the sine law, but I thought I'd show the cosine law here with this word problem. Feel free to try this, solving this using the sine law, see if you can get that 12.87 as well. This concludes the lesson on cosine law. Keep in mind, cosine law is used if you have side, 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 or if you have side, angle, side. Thank you.